Okay, before we know about the main operations for the queue and auxiliary operation. Oh, sorry, this is queue. I missed this one. This is queue. Okay. We know those 5, they are similar with the stack. When we learn about the stack, you have the main operation for the stack and you have auxiliary operation for the stack. Queue also the same. You have the main operation for the queue and you have the operation for the queue. And we have the exception. It means that whenever we attempt to dequeue, so the dequeue means we want to remove the element or from on an empty queue. So it is I'm going to check whether there is an element or not. So I'm going to check this one. So there will be a kind of exception. So the same with the stack. Yeah, we can have the also the exception. Now you can see the queue. Let's suppose we start with an empty. Then if we do the NQ 5, the element will start with 5. When we NQ with 3, then the element now becomes 5 and 3. We want to know how many items do we have in the queue. So now there are 2 because we have 2 elements. We want to dequeue. When we dequeue means we start from the first element. So the first element is 5. Then the remaining items in the list is 3. What is empty? I'm going to check whether the list is empty or not. But the fact that I'm still having 1 item, then the return value will be false. TQ. So I'm going to remove. Now it becomes empty for the list, and 3 is the return value. I'm going to check is empty. Yes, it is true because no element. TQ. This one is empty. So you cannot do anything. That's why this message appears. So this is an error message. NQ. It means I'm going to put a new item in the list. So I have 7. I have NQ 9. So I have another item at the end of the list. I'm going to check what is the first item. The first item is 7. So I can see 7. NQ. So I'm going to add another element at the end of the list. I'm going to check how many items now I have in the queue. So there are 3 items. And then TQ means I'm going to remove the first element. So I'm going to remove the element 7. There are many direct applications you can use for the queue. For example, yeah, you can use for the waiting list or the bureaucracy. If you are using in the programming, let's say you are going to print a document. If you access to the shared resources like the printer, so you need to have a kind of queue. Document number 1, it goes first. And then document number 2, it goes next, and so on. Multi-programming. So this multi-programming also can be applied with the queue. In some indirect application, you can use this queue for the auxiliary data structures for the algorithms. And you can use it for the component of other data structures. Now, when you use the queue, we can also use the same like stack. We use array for the application of the queue, or we call it array-based queue. We use an array of size n in the circular fashion. We call it circular or cycle. We have two variables to keep track of the front and rear. So F represent front, R represent rear. If you do with this array, we have this configuration. We call it, this is normal configuration. F, it indicates the index where the front is. And R indicates the rear. Array location R is kept empty. So it means I have no items in the R. So this is the front, this is the rear. Let's say I'm going to dequeue. So if I dequeue means I will remove this one, and then F will go here. If there is a new item entering the queue, then this item will go here and R will go here. What about if R already here? If R already here, then after adding a new item, R will go back to this index 0 because index 0 is empty. And so that's why we call it, this is a wrap around configuration. When an item goes, or when the item remove, the front will go next, will go next, will go next. And the R, once it is already full in this array, then it will go from index 0. This is we call as wrap. In this case, the array has a fixed size. Okay. So the size is fixed. For example, in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17 size. And while the size already fixed, whenever we have full capacity, then you cannot enter the queue. Once a person goes out from this front, then it will be empty and the other person can enter the queue. In the queue operation, we need to know about size and we need to check whether it's empty or not. In order to check the size, we can use this formula. So we use the modulo operator or the remainder of division. If you see this one, I'm going to check now how many person or how many items in the queue. We can use this formula. N is the number of the array size minus F plus R modulus pi. What does it mean? Let's see this one. Now F is here and then R is here. What about the N? The N is 17, okay, the one that I mentioned to you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, there we have 17 slot or we have 17 size. And then I'm going to check what is the F. F is the index 4. Okay, 0, 1, 2, 3, 4. So this is the index 4. And then R is in the index 40. Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is index 40. In order to know how many people or how many items in the queue, then I can use this formula. 17 minus 4 plus 40. Then it is 17 minus 4 plus 14, it is 27. 27 mod 17. What is the result? It is 10. So you will have 10 number of queues. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so using this formula, we know that, okay, the queue size is 10. Now, let's say now the queue is something like this one. The front is here and the R is here. So we can use the formula again like this one and check what is the size of this queue. We have N, this is 17. F, where is F? We need to check. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here is 11. What is the index R? The index R is 4. Then using this formula, 17 minus 11 plus 4. Then you will get 10. 10 mod 17. The result is 10. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the size of this queue are 10. If those queue is empty, then we can have F equals to R. So F, if the index F and R is the same, then it is empty. Now, we also need to check if we want to put the NQ or we want to put a new object into the queue. Operation NQ throws an exception if the array is full. If the array is full, just put the exception. So we do not need to grow the array. We do need to grow the array because sometimes if the capacity is full, you cannot get more customers. If the capacity is full, you cannot get more trucks and etc. So the exception is implementation dependent. Yeah, you can define the exception later. Now, if I'm going to NQ, I'm going to put this object into the queue. First, I need to check the size. What is the size? If the size is n minus 1, we know that this queue we have 17. So how to check the size? The size is from this one. Okay. The size is from this one. If the size equals to n minus 1, then we just say that it is already full. So you cannot put another item. If it is not the case, then okay, let's put the new item in the R position or in the rear position. And then after you put on the R, now let be the R equals to R plus 1 mod n. What does it mean? It means that I'm going to update the value of R, and let's say if R is already in the index 16, if R is already in the index 16, then you cannot add in the index 17. Then if it is already 16, 16 plus 1 mod 17. Then 17 mod 17 is equal to 0. Then it means R will go to the index 0. Okay. For example, this one, yeah, we have the F is 4 and R is 40. If I have a new item here, then the new R will be R plus 1 mod n. R is 14 plus 1 is 15 mod 17. Then the new R is 15. If R is 4, then I'm just using the R equals to R plus 1 mod n, and then we have the 5 mod 17. Now it becomes 5. What about DQ? It is the same with the R. If you want to check whether it is active or not. Okay. So the first we will check the is empty. If it is empty, just go to the exception. It means I cannot DQ or you cannot remove the element. Else, yeah, just call the index of the front or the QF, it is the front. And then F will be updated with F plus 1 mod n. So this is the same with the R. And then return O. O is the object that you have been removed. Okay, so the same with the formula. F plus 1 mod n, F plus 1 mod n to update the front. Now we will take a look on the Q. So we have also the data with underbar. It is to check with the fixed capacity and the size. Yeah, we want to know how many items that the Q already have until now, and then front. So it is the index to represent where is the location of the current front. This is the array Q. Okay. So let's just check with the code. In the round robin, there is another kind of algorithm. They call it round robin schedulers. So the round robin schedulers means it is a kind of scheduling algorithm that assign a fixed time slice to every process in equal cyclic order. So if you have operation here, operation here, operation here, here, and then you will dequeue, and then go to the shared service. After queue again, and then it goes back to this queue, and so on. Okay. So we call this is the round robin scheduler. The implementation will be using the dequeue and enqueue. Once you dequeue, it will go to the service, and then after the service finish, you will enqueue again. So this is the round robin scheduler. So let's go to the Google Colab. Use the array Q. Okay. The array Q means I'm using the list to define the capacity. Let's say the capacity is 10. So I'm going to make none for 10 times because this is based on the default capacity. I'm going to define the size and front. Length means I'm going to check how many elements do I have in the queue. It's empty, so I'm going to check whether the queue is empty or not. If the size is 0, then of course it is empty. I'm going to check the first. First means the element at the front. If this one is empty, so put the queue is empty. Yeah, now I'm just eliminating this one to make it just a simple one. If it is not empty, so get the element at the front. If you dequeue means I'm going to check the data at the front. If it is empty, then run the exception. If not empty, then let's get the data at the front. And then let's make the data at the front equals to none. That means you will make it empty. And then you will update the front number or the front index. It will be front plus 1 divided by the length of the data. And then the size will be minus by 1. If you do NQ, okay, it depends how you want to do. Okay. If you want to keep the size of the array the same, then you do not need to doubling the array. So this is doubling the array size. If the size equals to the length, yeah, I'm using this one to increase the array size, or this is the doubling strategy. After you doubling the array, then yeah, we want to update this available size. So front plus the size, it modulus by the current data size. And then the available will be the E, and then the size will be added by 1. For the resize, yeah, we already learned from the previous chapter about array. We can doubling. So this is the doubling strategy for the growingable array. So if you run this, yeah, this is the result, the same as the table that I show you in the PowerPoint. So if you look at the data, you can see like this one: none, 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 9, 4, none, 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 none. So we have only 2 elements, but the position is not always in the first. Okay, the position can be in any other index. This is a circular queue, so the one that I show you before. So the remaining is just the same, but we have the rotate. It means once you've already in the size limit, yeah. So the tail will be the tail dot next. It is more related to the linked list, so I will continue with the linked list. Okay, because of the time, I think I will just finish until this part, so we can do the quiz.